Good evening, and once again welcome to my YouTube channel, Maths with Ease by Mr. Kamotho. And this is video number 1 of the topic number, I think 20 or 19 of IGCSE 9 to 1 Mathematics A. And this is quite an important topic, because it is a topic where we introduce ourselves to three-dimension calculations through figures or three-dimension calculations. And in this particular video, I want to explain question number 1, which talks about A, B, C, D, E, F, G, H is a cuboid. First of all, we must understand what is a cuboid. A cuboid is a rectangular prism that has a rectangular cross-section, as you can see. This one is a rectangle. The top face is a rectangle. The side is a rectangle, and the bottom is a rectangle. Now, it has this cross-section. We can have this cross-section, and we can also have this face as a cross-section. But having understood that, we are told to find to three significant figures the length EG. It is important and paramount for any student to understand that all faces here are rectangular. They are rectangular. And because of this reason, we would want to keep pulling out every face that we are interested in and segregating that particular portion or part of this prism and work on it. The diagram, the way it is drawn right now, it is because of the 3D, and some angles may seem not to be 90. For example, if you look at angle EHG, this angle here, it doesn't look like it is 90. But remember, this is 3D, 3-dimension. When we draw diagram in 3-dimension, angles look distorted, but of course, the prism here, every angle is 90 degrees. Let us go to the question. Find the length of EG. You can see EG is a diagonal of the base face, of the face EFGH. So if I may want to pull aside that face, I will come here and have it like this. I will have it like this is EFGH. All these angles are 90 degrees. They are right angles. So what we are supposed to calculate is the length from E to G. And I must say, HG is already 10, we are told in the question, and GF is 3. So it goes without saying, because we know the kind of approach we can give this question to answer it, we know that EHG becomes a right-angled triangle at this point. And because this is 3 and this is 10, therefore EG becomes the hypotenuse of that triangle. What does that mean? If we employ the Pythagoras theorem, we'll see that EH squared plus HG squared is equals to EG squared, meaning that 3 squared plus 10 squared is equals to EG squared. It goes without saying, this is 9 and this is 100. So 109 is equals to EG squared. If we take the square root of both sides, it means that EG now is equals to the square root of 109. And that is the best answer. Though the question is talking of to 3 significant figures, that is the best answer, is the most accurate, root of 109. But because the question requests that we look at it to 3 significant figures, then the square root of 109 become 10.4. This is 10.4 centimeters to 3 significant figures. That is part A of that question. Part B of the question is asking us to get the length of CE. The length of CE. The length from C to E, it is a diagonal from the top right to the bottom left. It is a length that is moving from the top corner of the box to a bottom corner of the box, but which are not on the same face. They are not on the same face. C is actually on the face DCGH and BCGF and ABCD. It is actually that vertex. And E, it is this vertex that joins that face, and the bottom face. Therefore, how then do we create a right angle triangle which involve EC? And I would want to look at it this way. First of all, we have already calculated EG. This is EG. That line represents the base. And because it represents the base, this line EG, it is at the same level with HG. So the angle EGC is also 90. It is also 90 degrees. That is 90 degrees. Meaning that we are having E, G, and C up there. And C up there. Such that now this is C, this is E, and this is G. This is 90 at that particular point. I want you to think of a line that is on the floor. A line that is on the floor, which is EG. And this floor is EFGH. A line on the floor. Now, GC, according to the diagram, is 5. GC is this, which is 5 centimeters. EG, as you have seen in the previous calculation, is the root of 109. So what is EC? Again, Pythagoras theorem. The root of 109 squared plus 5 squared is equals to EC squared. EC squared. And the square root of 109 squared is actually 109 plus 25 is equals to EC squared. What is 109 plus 25? 109 plus 25. This is 134. So we are simply saying EC squared is 134. Getting the square root of both sides, we find that EC is actually the root of answer, which is 11.57, which is 11.6 to 3 significant figures, and these are centimeters. That is part B. What about part C? Let us find out what part C is asking us. And part C is asking us to find the angle CE makes with the angle this line CE makes with the plane EFGH. EFGH. The angle CE makes with the plane EFGH. Of course, this is the angle we are expected to calculate. CE and the plane EFGH, because we agreed that the line or the diagonal EG represents the bottom face, meaning that if we apply now the SOHCAHTOAs or trigonometric ratios, we are going to say that the tangent of theta, let's call it theta, this is angle theta, is given by opposite side over the adjacent side. And the opposite side, you can see it's 5, and the adjacent is the root of 109. So the tangent of theta is 5 over the square root of 109. Let us find out what is that. 5 divided by the root of 109. And that is 0.479. And for the accuracy purposes, we know that the theta is going to be the tangent inverse of 5 over the root of 109. And therefore, shift turn answer, we say now the angle theta is 25.6 degrees. That is how we have been able to solve that question. Quite an important question. And let us see how we can follow. It looks like a complicated question, but it is not. The only thing we need to know is to find out how we can get right angles triangles and solve them. 3D is the topic. Let us follow and let us meet in the next video. Thank you.